Okay, so this is a good result. It's very interesting, but the question is why? Why does it work? There could be many reasons, because you're not just changing one variable. You're reducing calories, but you're changing the balance of the macronutrients. You're probably changing lifestyle. It's really hard to control for. The theory that most people favor is that you're reducing oxidative stress. That, when you're exposing yourself to a lot of the ingredients in our food today, those create free radicals, and that leads to a whole progression of disease. There's an alternate theory, which is the one I actually believe is true, which is that it's kind of the opposite theory. It actually increases your stress resistance through a process called hormesis, which I think is actually much more powerful than directly trying to block antioxidants. So hormesis. I'm really going to talk about hormesis as it applies to eating and dieting, but it actually is a general biological principle, and I'll list some of the other applications here. Allergen immunotherapy. Most people treat allergies by avoiding the allergens. Allergen immunotherapy actually exposes you to small quantities of the allergens. Bioflavonoids for immunity, to stimulate the immune system. Cold showers, one of my favorite examples of hormesis, which not only helps with weight loss and energy, but also is pretty effective as an antidepressant. Lifting weights to grow muscles, what Johnny and the whole group do here every day, that is hormesis. You're actually damaging your muscle tissue, and you're allowing a rest period for it to grow back. Use of plus lenses to correct for myopia. This might seem a surprising one, but if I had shown you a picture of myself from the year 2000, I had thick glasses on, and I was able to wean myself off of those by, again, using a form of hormesis, which I won't talk about today, but I would encourage you to read about it on my blog. Exposure therapy for phobias and anxiety, a psychological form of hormesis. Barefoot running to prevent and reverse injury. Again, seems counterintuitive. You'd think you would be getting more injury by running without shoes, but actually it stimulates a process where your muscles and your tendons get stronger, and you're less prone to injury, and also the arch of the foot is stimulated by this, gets stronger. And also there's a lot of controversy about the role of UV in cancer, but there's actually a certain dose that helps stimulate melanin synthesis and vitamin D synthesis and protects the skin from cancer. Now all of these require a certain level of optimization. You can go too high in the stress and get the opposite result. But let's now talk about hormesis as it applies to diet. So what is hormesis? It's a universal principle by which a stress, or you might call it a stimulus, if you don't call it a stress, stress is negative, stimulus is positive. A stress that would be harmful at a high dose is actually beneficial at a low dose because it promotes defense mechanisms, it promotes repair mechanisms, and it strengthens the organism. So how does that apply to calorie restriction? There's numerous ways, and I'll only illustrate three of them. One is called autophagy, the second one is called mitohormesis, and the third is the production of a neuroprotective factor called BDNF. So what's autophagy? This is a really interesting process, and this is one I actually think about mentally when I'm practicing intermittent fasting. It literally means self-digestion, and it's a genetically programmed process whereby a cell, when it's depleted of nutrients and is low on energy, and it turns on the insulin, activates a process by which membranes or vesicles form within the cell that grow and encapsulate the damaged proteins and the damaged DNA and wall them off. And my analogy is it's just like a spider, covering its prey in a web of silk before it eats it. It's encapsulating it. And here you can see some pictures of autophagy occurring in the cell. These little vesicles here, the dark patterns, are areas that have been walled off by a cell that's in starvation mode. And then what happens is it isn't just removing these toxic damaged products, it's digesting them and using them as energy. So it's basically a recycling process that takes place, but it only takes place when you are not eating, when you allow yourself to start fasting and when you turn on these processes.
Is this in the liver?
This is in literally every cell of your body. And it's in brain, for example. This process is neuroprotective against Alzheimer's and dementia. And it occurs to basically any damaged or glycated proteins, where the protein has reacted, say, with glucose or sugars, or where the DNA has been damaged. It's a general cellular defense mechanism that occurs in all different kinds of organisms, right? It activates, it's activated by insulin, by IGF-1, and by growth hormone being at low levels, right? It's basically a recycling process. So that's autophagy. A second process is called mitohormesis. Now, what happens here is there's, in every cell, a little energy factory called the mitochondria. And this really provides the basis for energy and energetics in the cell. Well, when the cell is stressed oxidatively, it turns on a set of genes called the sirtuin genes. And these in turn activate production of some enzymes which increase the activity of the mitochondria. So it actually revs up the cell, makes it more energetic, provides a better defense against that oxidative stress. So that's the second principle. And this is just a small worm that's been studied where they limited the glucose fed to the worm, and they showed that this process, these genes turn on, the enzymes turn on, the mitochondria ramp up. So they really proved the model in this very simple organism. So it doesn't just occur in us, it occurs throughout the animal kingdom. One thing I would point out here is this is really the opposite of the oxidative damage theory, right? Oxidative damage theory says that starvation or calorie restriction works by protecting ourselves against oxidant. This says actually the starvation is inducing oxidation, and the body's responding to that by upregulating its mitochondria. So it's taking you in opposite directions depending on what the data would say. The third mechanism I want to talk about is brain-derived neurotrophic factor. It's a long mouthful, BDNF, but it's a very important neurotransmitter in the brain. And it's involved in what they call neuroprotective effects. For example, in warding off Alzheimer's. The way that it does this is it stimulates the neurons in the brain to become more adaptive, more plastic. It stimulates connections between neurons, and it protects against some of these stresses. The BDNF factor is something you can measure in a cell, and what really turns it on is calorie restriction, exercise, omega-3 fatty acids, these type of dietary factors, and the opposite happens when you have a diet that's high in calories, in sugar, in fats. This tends to suppress the BDNF. And in studies of insulin-resistant people who went on a 25% calorie-restricted diet, they were able to show their BDNF levels ramped up within 3 months, which is pretty impressive. So that shows you that you can actually recover from this. Okay, so those are just 3 mechanisms. There's a lot written on that, but I wanted to give you some sense of why calorie restriction might work. It still doesn't answer the question. Is it really due to just eating fewer calories? Is it due to the fact that you're leaner and you have a lower body mass, and so you're producing less insulin? Is it the average calories you're eating, or is it even just periods of nutrient depletion? Well, some of those processes that I showed you there, which are activated immediately by a low insulin level, would suggest that it's even intervals of low calories that can activate this process, that you don't have to be calorie restricted the whole time for these processes to kick in. So that's the mystery. The other thing I want to point out is there's kind of a problem that you deal with when you think about calorie restriction. First of all, hunger. Some people can cut their calories back 20 or 25%, but it's very hard to do for most people. You're feeling hungry around the clock, and it's just not very pleasant. The other problem, and if you go back to that picture of Ray Walford, you see you lose muscle mass. You know, you become lean, but it's hard to build that muscle mass. You need to eat a certain amount of protein and fat and a little carb to stimulate the growth of muscle, to turn on your human growth hormone. So if you're always a little bit deprived, you're going to have trouble keeping that body mass. So those are two significant problems. Right? So is there another way to get the benefits without these downsides? And I think there is. The key is, come back to the principle of hormesis here. All of these mechanisms that I mentioned only happen when your insulin levels are low. The insulin levels are high, it turns them off. People with hyperinsulinemia, high insulin levels, don't have these processes going on in their body. So how can you get those benefits without having to go on a starvation diet?